Hello, students. Am I audible? Please check. Hello. Let me know who is online. Please let me know. I just completed M3 live lecture on Fourier series. We just ended 10-15 minutes back. Now we're starting with M4 lecture, that is complex integration. And in complex integration, we will see Laurent series. Laurent series is basically a part of complex integration. There are four major chapters or subtopics, you can say, complex integration. One is Laurent series, next is Cauchy theorem, then residues, and finally line integration. So there are four parts in complex integration. Are from Parmanan, hi, good evening. Hope good to see you again. So complex integration, we have four chapters in complex integration. The first one is line integration. Let me write it down. What is the chapter? What are the different chapters in complex integration? Then we have Cauchy theorem. Then we have residues. And we have Laurent series. So these are the four chapters under complex integration. We today will discuss about Laurent series, and obviously in the next live streaming, we'll discuss the remaining topic. So starting with the first topic, Laurent series. It's an individual topic, not related to any other topic, and confirm comes in the exam. Fix it comes in the exam. Laurent series. So let us start with the first problem on Laurent series. Before going ahead, one point that you need to remember. If you remember this point, you can easily score marks. And the point is, inside constant, outside set. Remember this point, and this will be the simplest chapter of your life. Inside constant, outside set. And the good thing about this particular chapter, Laurent series, is there are not much variation. So if you understand one problem, you can easily manage all the problems. So there is no variation actually. So inside constant, outside z, yeah, that thing you need to remember. And there are a few basic formulas. 1 minus x inverse will be 1 plus x square plus dot dot dot, and 1 plus x inverse. It will be alternate plus minus. So these are the two basic series formula that you need to remember. These are the basic formula that we have already learned in the previous academics. 1 minus x inverse is, if both are negative, everything is positive. See here, minus and minus. If both are negative, everything will be positive. And if it is plus and minus, then we'll have alternate plus minus. 1 plus minus, and so on. So these are the basic things that you need to remember. And after that, let us start with the first problem of Laurent series. With the basic discussion, now we're starting with the first problem. Obtain all the possible Laurent series expansion of f of z is equal to 1 upon z, z minus 3, z plus 2, about z is equal to 0 or origin. about z is equal to 0 or origin. So this is the problem that we're going to solve here. We need to find it out all the possible Laurent series expansion of this particular series. Okay, so let us start solving this problem. Very simple problem. There is nothing difficult in it. There is a procedure. If you follow this procedure, you can manage all the problems of Laurent series. Generally, it comes in the exam for 6 to 8 marks. So let us start. The first step is, see, the first step is a basic step. You need to separate this factor by using partial fraction. So we need to use partial fraction here. Always fixed. Steps are always fixed here. The first step is partial fraction. Step number one is partial fraction. It is always fixed. And why doing partial fraction? Because this is a part of gate or not. Yes, this comes in the gate exam, but actually, Paramanand, this is our academics lecture, not gate lecture. We do have different lectures for gate. Basically, here we are focusing into academics, how to write it down in the exam. So gate, for gate we have different lectures, but obviously it comes in the gate exam. So at least the concept will be clear. So if you attend this lecture, but this is, the focus is not on gate, the focus is on academics. We do have different lecture series for gate also. Okay, so let us start. The first is partial fraction. So we need to write it down. The first step is fixed, is partial fraction. And what is the purpose of partial fraction? The purpose of partial fraction is always we need to convert these three factors which are in multiplication in the denominator. See here, z minus 3, z plus 2, all these factors are in multiplication. Will convert it into plus or minus. So the first step is fixed. Let 1 upon z, in all the problems of Laurent series, the first step is a partial fraction. A upon z, b upon z minus 3, and c upon z plus 2. This is not related to Laurent series. This is your basic partial fraction. See here, all these factors are linear factors. Z, z minus 3, z plus 2, all are raised to 1. See here, raised to 1, raised to 1, raised to 1. Since all the factors are linear factors, so they will be separated as a upon, b upon, and c upon. What is next? For solving partial fraction, we take LCM. So let's take the LCM here. What will be the LCM? Obviously, all these three terms will be multiplied. So this is your LCM. With A will be having these two terms. With A multiplication, this is simple LCM. Z minus 3 and Z plus 2. With B we'll ignore this term Z minus 3 and we'll write down Z and Z plus 2. So here it will be Z and a Z plus 2. With C, the denominator is Z plus 2. Ignore Z plus 2 and write it down Z and Z minus 3. This will be cancelled from both the sides. Our aim of partial fraction is to get the value of ABC. And what is the procedure of getting the values of ABC? For getting the values of ABC, you need to substitute. So there are three substitutions that I'm going to put here to get the value of ABC. Put, and put. Three substitutions. What are the linear factors in the problem? See, Z. Z is a linear factor, therefore I'm going to put Z equal to 0. The next linear factor is Z minus 3, so Z minus 3 equal to 0. And what is the next factor in the problem? Z plus 2, so Z plus 2 is equal to 0. See, this is a partial fraction, so it's not related to Laurent series. You can solve in any way, partial fraction, the way you like. So what I'm doing here, there are three linear factors, so I'm substituting it as a 0. So Z equal to 0, then we have Z minus 3, Z minus 3 equal to 0, and finally we have Z plus 2. So Z plus 2 is equal to 0. So this means Z equal to 3 and Z means Z equal to minus 2. Let us put these values in the above equation. If I'll put Z is equal to 1, Z equal to 0, in the numerator we have 1. And if I'll put Z is equal to 0 on right hand side, on this particular side, so what will happen? It will be A. If I'll put Z is equal to 0, this is minus 3. And if I'll put Z is equal to 0, this is 2. So minus 3 into 2 is minus 6. If I'll put z is equal to 0, so this is 0 into anything is 0. So this is the entire term is 0, and this term is also 0 because z is 0, so 0 into anything is 0. So the entire term will be 0. So in short, the value of a is equal to minus 1 by 6. Next, let us put z equal to 3. So LHS is 1. If I'll put z equal to 3 on RHS, the first term, this term will be 0. How? If I'll put z as 3, so 3 minus 3 will be 0, and 0 into anything is 0. So the entire term will be gone. Again, the entire last term will be gone because if I'll put z is equal to 3, so 3 minus 3 is 0, and 0 into anything is 0. So entire term will be gone. I'll be left with only this particular term, middle term. So let me put z is equal to 3 here. So this is 3 and this is 3. So 3 plus 2 is 6. 3 plus 2 is 5. 5 3s are 15. B value will be 1 by 15. Likewise, I'm going to get the value of C. For that, I'm going to put z is equal to minus 2. So this is 1 equal to, if I'll put minus 2, so minus 2 plus 2 will be 0. And 0 into anything is 0, so the entire term will be gone. Minus 2 plus 2 is 0. 0 into anything is 0, the entire term is gone. If I'll put minus 2 here, so this is C minus 2. If I'll put minus 2 here, so minus 2 minus 3 is minus 5. Minus minus plus, that is C is equal to 1 by 10. We got the three values A, B, C. That is minus 1 by 6, 1 by 15, and 1 by 10. Therefore, our basic problem, that is f of z equal to, got converted into CN. This was the problem, and this is equal to this particular expression. So let us put A, B, C value in this particular expression. What is the value of A that we got? We got minus 1 by 6. So here it will be minus 1 by 6 upon Z. What is the value of B? See here, what is the value of B? B is equal to 1 by 15 upon Z minus 3 plus, what is the value of C? See here, C is 1 by 10. And here it will be Z plus 2. Till now, we haven't started with Laurent series concept yet. The problem was given and we need to find it out all the possible Laurent series expansion of this particular function. Till now, we just did partial fraction and we separated these factors into plus or minus. So now we'll start with Laurent series. Till now, we haven't done with Laurent series. Now we're starting with Laurent series. Okay. So let us start. Now the concept is very important. So if you understand one problem, you can manage all the problems. Okay. So let us start discussing the problem. First of all, in 99% of the times, in case of Laurent series, there will be three cases. See here. Here it is mod set. Now, what do you mean by mod set? Mod set means we'll assume z equal to 0. This is z, right? This is z. And we always take mod. So in short, the first is mod z is equal to 0. So from this is mod z is equal to 0. This is actually z equal to 3. If you equate it to 0. Now listen to it very carefully. This is z equal to 0. The second term is z minus 3 equal to 0. That means z equal to 3. If I'll equate it to 0, so this is z plus 2 equal to 0. So z plus 2 equal to 0 means z equal to minus 2. Is this clear what I did? See, this is z equal to 0. Just equate it to 0. This is z equal to 0. This is second factor is z minus 3 equal to 0. So z minus 3 equal to 0 means z equal to 3. And the last factor is z plus 2 equal to 0. That means z is equal to minus 2. But we always take mod. Okay, so the first is mod z equal to 0. We always take mod. The second is z is equal to 3, but we take mod. So that is mod z equal to 3. And finally, z equal to minus 2. Z plus 2 is equal to 0 means z is equal to minus 2. But we always take mod. So that is mod z equal to 2. Is this clear till now? Please let me know. So we got three circles from this. What do you mean by mod z is equal to A? Its meaning, circle with radius a. So this is the meaning mod z is equal to a, means circle with radius a. Is this clear till now? Always 99% time you get three circles, or you can get four, or you can get two. It depends. But from where you're going to get the circles? You're going to get the circles from the denominator. See here, this is z. That means z equal to 0. So we always take mod z equal to 0. This is z minus 3 equal to 0. That means z equal to 3. That means mod z equal to 3. And finally, z plus 2, that is z equal to minus 2. But we take mod, therefore it will be positive value. Now let us draw these circles. Mod z is equal to 0. Mod z is equal to a is a is what? Circle with radius a. So mod z is equal to 0 means circle with radius 0. So obviously circle with radius 0 means a point. So this is your mod z equal to 0. Circle with radius 0 means it's a point. Next, mod z is equal to 2 means circle with radius 2. And the last is mod z is equal to 3 means circle with radius 3. This is called your ROC, that is region of convergence. This is called ROC, that is a region of convergence. And how we draw region of convergence? It depends upon poles. And what do you mean by pole? Equate denominator to 0 and you will get the poles. So this is z equal to 0, that is mod z is equal to 0. From this you will get z equal to 3. And from this you will get mod z is equal to 2. And we'll draw this. Okay, I'm going it very slow because I know once you understand the first problem, you can manage all the problems of Laurent series. So therefore, I'm going it very slow. Now, in all the problems of Laurent series, there will be three cases. A point may lie here. A point may lie here, or point may lie here. So what are the possibilities? See, a point may lie here means inside this smaller circle. What is the next possibility? A point may lie between these two circles, this one and this one. And what is the last possibility? Outer, out of both the circles. So there will always be three cases. What is the case number one? What is case number two? And what is your case number three? What is your case number one, case number two, and case number three? See here, this point is lying inside the smaller circle. That means, see, mod z less than 2. You assume this mod z as point. This point, see, this point is lying inside this particular circle. That means less than, inside means less. Here, now the second point, this is the point, it's lying, it's outside the circle and inside this particular circle. That means this point is lying between 2 and 3. And finally, point is lying outside this bigger circle. So that is mod z greater than 3. Inside means less and outside means greater. Are these three cases clear? See, let me repeat again. Point is lying here. That means inside this smaller circle. Therefore, mod z less than 2, because this circle equation is mod z less than 2. See here. Point is lying here. That means outside 2 and inside 3, because this outer circle is 3. So that is 2 and 3. And point is lying here. That means outside this bigger circle, that is greater than 3. Is this clear? If not clear, let's take one more example to understand. See here, suppose in the denominator, suppose you have, see here, let's say you have z, let's say you have z minus 1, let's say you have z plus 2, and let's say you have z minus 3. Now please tell me from this particular example, what will be the poles? First is mod z equal to 0. From this we got mod z equal to 0. What about this? This is z equal to 1. That is mod z equal to 1. This is z equal to minus 2, but we always take mod, so that is positive. That is mod z equal to 2. And from this is mod z equal to 3. If I draw the circles, so this is your mod z equal to 0. What next? This is your mod z equal to 1. Next, this is your mod z equal to 2. And what is the final? This is mod z equal to 3. So now how many cases are possible here? See here, a point may lie here, may lie here, may lie here, or may lie here. If the point is lying here, that means inside this particular circle. So what is the equation of this circle? This equation is mod z is equal to 1. That means the case number 1. There will be 4 cases. There will be 4 cases. The first case is point is lying here. That means inside this smaller circle. And what is the equation of the circle? See here. Mod z is equal to 1. So that means mod z less than 1. What next? A point is here. That means it lying between 1 and this circle is 2. So the point is lying between 1 and 2. Next, this is the point. That means a point is lying between 2 and 3. And finally, point is here. That is outside 3. So that is mod z greater than 3. So this is the way we write it on the different cases. So let's come back to our problem. We are here. There are 3 poles. So from these 3 poles, we draw 3 circles and we took the 3 different cases. So let us start individually for each case. Case number 1, mod z less than 1. That means in all the 3 cases, you need to draw the ROC. Here it is mod z equal to 0. Here mod z is equal to 1. And finally, outside mod z equal to 2. So basically, in the first case, we are talking about this ROC. Mod z is equal to 1. That means we are assuming that the point is inside this particular circle. And what is my f of z? Minus 1 by 6z plus 1 by 15 z minus 3 plus 1 upon 10 z plus 2. So this is the function. See here. See here. Now for solving Laurent series problems, the most important thing, or you can say trick from my side. If you remember this point, these problems will be very simple. So this is the trick from my side, inside constant, outside side. Remember this trick and you can easily manage the problem. So what I'm trying to say, we'll understand from this. What the trick saying? Inside constant, outside side. Inside constant, outside z. Okay, so let us check. Let us start. See, first term, we're going to keep it as it is. Why? I'll let you know soon. Just follow me what I'm saying. Just follow me. I'll let you know soon. First term, keep it as it is. Okay. Let's discuss the next 2 terms. I'll tell you the reason why. Just wait for some time. First term, keep it as it is. Let's move on with the next term. See here. This is z minus 3. Now, please tell me, is this point? See, the point is lying in the shaded region. Let's say somewhere around here. In between. Let's say here. Now, please tell me, is this point? This is what z minus 3. That means mod z is equal to 3 in short, because we equate it to 0. So this is z equal to 3. So that is mod z is equal to 3. Mod z is equal to 3 means this outer circle, this one. So this particular point is lying inside this circle. It's very clear. And this is what? This is mod z is equal to 2. Mod z is equal to 2 means which circle? See here. Mod z is equal to 2 means this circle. That means this point is lying inside mod z is equal to 2 also. It's very clear. By looking at the diagram, you can easily say this point. See, anywhere inside this shaded region, a point is lying inside mod z is equal to 2 as well as inside mod z is equal to 3. Point is lying between mod z is equal to 2, inside mod z is equal to 2 and mod z is equal to 3. And if it is inside, we're going to take constant common. If it is inside, we're going to take constant common. See, there are three cases. So if you have any confusion in case number one, please be patient. It will be clear in case number two. If it is not, then it will be clear in case number three. So be patient. It will be very clear. Don't worry. Okay. So see here, case number one, point is here. That means it is inside mod z is equal to 2 and inside mod z is equal to 3. And if it is inside, we're going to take constant common. So please tell me what is the constant here? See here. The constant is minus 3. Here the constant is minus 3. So you're going to take constant common. So if you take minus 3 common, what do you mean by taking common? Taking common means dividing. So if you take minus 3 common, that means you're going to divide both the terms with minus 3. So this will become minus z by 3 plus 1. See, we are done with step number one. What was the step number one? Partial fraction. See here. We are writing down the step also. So step number one is partial fraction. Step number two is take common. You follow the step, the problems are simple. Take common. Now what to take common? It depends. Either to take constant common or to take z common. Okay. So let's take common. See here. The point is actually in this case, the point is inside both the circles. And if it is inside, we're going to take constant common. So let's take minus 3 common. So if you take minus 3 common, taking common means dividing. Both the terms will be divided by minus 3. So this first term will become minus z by 3 plus 1. Again, constant common. Because point is inside this circle also. So this is step number 2 done. Next step. Convert problem into 1 plus or 1 minus form. This is the next step. Convert the problem into 1 plus or 1 minus form. So see here, the first term will remain as it is. Throughout the solution, it will remain as it is. This is actually minus 1 by 15. I hope you understood. This phi is actually in the denominator, that is minus 1 by 15. 1 upon, let us convert this problem into 1 plus or 1 minus format. So 1 plus 1 minus format means you just need to swap the terms. That means first write it down 1 and then write down this term. So if I write down 1 first and then z by 3, so this will become 1 minus z by 3. So first I will write 1 and then minus z by 3 plus 1 upon 20. Again, if I write down this term into 1 plus or 1 minus format, this will be 1 plus z by 2. 1 I'll write it on first, then plus z by 2. What next? Step number 4 is take it up and take it up. So see here, minus 1 by 6 upon z as it is, minus 1 upon 15. If it goes up, this will become inverse. This term goes up, that will become inverse of the bracket. This will be inverse, and we have formula for this. What is the formula? Is already discussed. 1 plus x square plus dot dot dot. 1 plus x inverse is, if both are minus, everything is plus. If it is plus and minus, we have alternate plus minus. These are the predefined formulas of series. So I'm going to apply these formulas here. Minus 1 by 6 upon z minus 1 by 15. See here, this is minus, this is also minus, so that will become plus. So this is 1 plus, both are minus, therefore everything will be plus. So 1 plus x, this term. But in place of x, we have z by 3. So 1 plus z by 3 plus x square. See here, x square, x cube, and so on. So in place of x, we have z by 3. So 1 plus z by 3, the whole square plus z by the whole cube plus dot 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 plus 1 upon 20. It is alternate plus minus, so that is 1 minus x. So in place of x, we have z by 2. Since it is plus and here it is minus, that means this formula is applicable, formula number 2, plus Z by 2 the whole square minus dot dot dot. That is it. We're done with the first case. That's it. Take it up, and step number 5 is expand. And we are done with the first case. So this is the way we solve the first case. Now we were solving the two more cases are left. Is this clear till now? So what we did, let us summarize it quickly so that it will be no confusion while solving case number 2 and case number 3. The first is the problem. This is the given problem. We will separate it by using the partial fraction, and based on that, based on these poles, we'll draw the regions, that is ROC, and from ROC we'll write it down the cases. Case number 1, this is the case. Now we'll discuss case number 2. So if you have any doubt, don't worry. If you have any doubt, no problem, it will be very clear. Stay tuned, it will be very clear. See, case number 2 is what? It's lying between 2 and 3. First of all, please let me know, did you understand case number 1? Please let me know in the live chat box. Please let me know, did you understand case number 1? Please write down, let me know, please. Little bit. I am Deepak, little bit. Don't worry, Deepak. I'll ask you the same question after case number 2. It will be very clear. Don't worry. Not clear, then I'll ask you after case number 3. Because the thing is that it's just a procedure oriented. So once you understand this, then it's simple. Let us start with case number 2. See, what is the case number 2? 2 less than mod z less than 3. That means we are talking about, let's draw this. This is mod z is equal to 2, and this is mod z equal to 3. And this is mod z equal to 0. Right, there are 3 cases as discussed. This is your original circle. Now in case number 2, the point will lie here. In case number 2, we discussed the point is inside this particular smaller circle. Now in case number 2, the point will be outside the circle too. See here, the point is here. That means outside this circle and inside this bigger circle. So inside mod z is equal to 3 and outside mod z is equal to 2. So it's outside this circle and inside this particular circle. So what is the given function? F of z equal to minus 1 by 6 upon z plus 1 upon 15 z minus 3 plus 1 upon 10 z plus 2. Let us start. See, first term will remain as it is, always fixed. I'll tell you why just in a little while once we're done with the problem. Now, please tell me the point is inside z minus 3 or outside z minus 3. Please let me know. Yes. Let me check how much you understood. Please tell me this particular point is inside z equal to 3 or outside z equal to 3. Yes, I'm waiting. Please let me know. Inside, yes, perfect, Deepak, perfect. See here, z minus 3. This is your point. This is inside the circle z equal to 3, and this point is outside this circle z equal to 2. Now it's clear. What is the note? If it is inside, we're going to take constant common, and if it is outside, we're going to take a z common. So this note is very clear. So this particular point is inside mod z is equal to 3. Since it is mods inside, therefore we're going to take constant common. So what is the constant here? Minus 3, you're going to take common. Right. So my steps are fixed. Take common. So we're taking constant common. So if you're taking constant common, that means dividing by minus 3. Now, if you talk about this particular point, this is z equal to 2. That means mod z is equal to t, this circle. So this point is outside this particular circle. And if it is outside, we're going to take z common. So let's take z common. So if you take z common from these two terms, that means both the terms will be divided by z. So this will become z by z, that is 1. Plus, if I divide by z, it will be 2 by z. So this is your step number 1. Step number 2. Step number 1 is partial fraction, that is done. Step number 2 is what? Take common. What next? Step number 3. Convert the problem into 1 plus or 1 minus format. So this is minus 1 upon 6z. Obviously, this is minus 1 upon 15. So this will be 1 minus z by 3. 1 plus 1 minus format means first we'll write 1, then we'll write this 1 upon 10z. How? This is 1 upon 10 and z will be multiplied. And in the denominator, we'll have, this is already 1 plus format. So no need to do anything. Step number 2 done. Step number 3 done. What next? We're going to take this term in the numerator. This term will remain as it is. So this will be 1 minus z by 3 inverse. This will be 1 plus 2 by z inverse. What is next? The next step is just step number 4. And the next step is step number 5. We just need to open the brackets and the work is done. So minus 1 upon 6z minus 1 by 15. If I'll open the bracket, both are minus. Therefore, everything is plus. So that is 1 plus z by 3 plus z by 3 the whole square plus dot 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 plus 1 upon 10z. If I'll open the bracket, this is plus and this is minus. So it will be 1 minus 2 by z plus 2 by z the whole square minus dot dot dot. So that's it. We are done with case number 2. Please check step number 2. Something wrong. Step number 2. Take common. No, it's right. See, take common means we need to take something common. So if the point is inside, we're going to take constant common. If the point is outside, we're going to take the z common. The point is, see, this is z is equal to 3. Z is equal to 3 means this outer circle. So point is inside. Therefore, we're going to take minus 3 common from these two terms. So if I'll take minus 3 common, so if I'll take minus 3 common, so that will become minus z by 3 plus 1. And from these two terms, actually the point is outside z is equal to 2. So outside means z common. So I'm going to take z common. So if I'm going to take z common, that means I'm going to divide by z. So that will become z by z. That is 1 plus 2 by z. So that is perfectly okay. Where? Acha, 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 yeah, it's a no, no. That's a mistake. I think then that mistake is yes, 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 yes. This mistake is done here also. See here. It's a silly mistake. This is 15. So 15 3 is a 45. So this will be 45. Yes, yes, yes. Sorry, sorry for this mistake. So again, wow, Deepak, very good. So this is 1 upon 45. And the same way, this is 15. So it will be 45. It will be 45. Yes. So done with case number 2. Now we'll discuss case number 3. Now you have the clarity, so we can do it easily. The last case is the point is lying outside both the circles. That is mod z greater than 3. See here. Now for the last case, the point is lying both the circle. This is mod z equal to 3. This is mod z equal to 2. And this is mod z equal to 0. Now the point will be somewhere here, that is lying outside both. So f of z is equal to, Now the question is, sir, now why you teaching M4 now SEM3, sir? Yes, yes, you see, actually, it's not about SEM3 or SEM4. In few universities, this topic, complex integration, is in SEM3, and few universities, it is in the SEM4. And few branches also, there is a difference. So that is why it's basically based on topic. So complex integration in few universities, this topic is there in M3 syllabus, and few universities it is in the M4 syllabus. So don't see M3 or M4. Check the topic. Okay, Jaydeep, clear? Next, minus 1 by 6 upon z plus 1 upon 15 y 1 upon z minus 3 plus 1 upon 10 z plus 2. So let's talk about the last case. In the last case, what is the question? Y inside constant, outside z. See, this is the format of Laurent series. If you the what this result, whatever you got, the result is in the Laurent series format. So if you want your problem to be in the Laurent series format, you need to remember that point. Otherwise, there is a complicated formula that you can apply and you can get this series. So remember the point, that will be easy. Jaideep, which university you are from? Mumbai University, right? Mumbai University. And what is your branch? Mumbai University. What is your branch? Because if you are from Mumbai University, if you're from Mumbai University, you might be knowing every branch has a different topic. So for a computer branch, uh, a topic must be there for computer branch. It may be not be there for EXTC branch. So see, it's not about M3 or M4. Complex integration topic, few branches, complex integration is in M3, and for few branches, complex integration is in M4. So therefore, I'm teaching this topic because few of the branches will have complex integration in M3 also. So therefore, I'm teaching this topic. The topic is important, not the branch, not M3 or M4. Okay. So if you have this topic, you can attend, no problem. Okay. So let us move on. Now, mod z is greater than 3. That means the point is outside both the circles. So in this case, and if it's you are from Mumbai University, 8 marks are guaranteed. Always come 8 marks, the 8 marks Laurent series. See, here the point is outside both the circle. The first point will remain as it is, plus. Yes, see here. Now this particular point is outside mod z is equal to 3 as well as mod z outside mod z is equal to 2. That means the point is outside this, and outside means z. Inside constant, outside z. That means you're going to take z common from this particular term. So if you take z common, it will be 1 minus 3 by z plus 1 upon 10. Again, this point is outside this particular z plus 2. This is a z plus 2 circle, and point is outside this particular circle. Again, since the point is outside both, outside means z, you need to take z common. So if you take z common, this will be 1 plus 2 by z. What is the next problem? What is the next step? Convert the problem into 1 plus 1 minus format. This is already 1 minus here. This is already 1 plus. That means no need to do any modification here. This is already 1 plus 1 minus format. What next? Take it up and inverse. So this is 1 upon 15z. 1 minus 3 by z will go up and will become inverse. 1 upon 10z. 1 plus 2 by z will go up and will become inverse. What is the next step? Expand, and work is done. So let's do it. minus 1 by 6z plus 1 by 15z. If I open, both are minus, everything will become plus. 1 plus 3 by z plus 3 by z the whole square plus dot dot dot. This is 1 alternate plus minus, because here it is plus, here it is minus. 1 minus 2 by z plus 2 by z the whole square minus dot dot dot. That is it. So this is your Laurent series expansion for case number 3. Now the point is, why we always keeping the first term as it is here. In the first case also, in the second case, in the last case, we always kept this term as it is, because the reason is, see here, for that purpose we need to check the problem again. What is asked in the problem? It is asked, obtain all the possible Laurent series expansion of f of z is equal to this, about z is equal to 0 or origin. So in this particular problem, we need to find all the possible Laurent series expansion about z is equal to 0. That means whatever will be the solution, see here, this is the solution from case number 1. It should be z equal to, it should be in terms of z. Your solution should be z in terms of z, because it is clearly mentioned in the problem about z is equal to 0 or origin. So your solution should be in terms of z. See here, see here, z, 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 z. So in terms of z, z square, z cube doesn't matter. And the first term is already z. Check here. First term is already z. Therefore, we are keeping the first term as it is. See here. The first term is already z. This term is not in terms of z. Therefore, we need to do some calculations. We need to find it out the expansion about z is equal to 0 or origin. The first term is already in terms of z. Therefore, we are not doing anything. We keeping as it is, or simple, or simply. Second reason. See, the main funda about Laurent series is we take common. If the point is inside, we take constant common. If it is outside, we take z common. For example, see here. For example, see here. Here we took constant common. See here, we took constant common. And from this term, we took a constant common again. This is only one term, and you cannot take common from one term. For taking common, there should be at least two terms. For taking common, there should be at least two terms. See, there are at least two terms. So we took something common. So whether it is a constant or z doesn't matter. We took common here. This is only one term. So you cannot take common from the one term. Therefore, we are keeping as it is. See here, if I'll talk about case number 2, we took a constant common from this and we took z common from this. This is only one term and we cannot take common from the one term. Therefore, we are keeping as it is. So this is the simplest reason why we keeping the first term as it is. And finally, whatever the solution we get, we should get in terms of z. See here, all the values are in terms of z. Z square, z doesn't matter in terms of our z. Therefore, we keeping the first term as it is. That is it. We're done with the first problem. And that's it. So concept is similar. Jaideep, what Jaideep is saying, sir, please give live lecture for electronic instrumentation and control system. Jaideep, on our channel, Ekeeda channel, there are a lot of live lectures going on. So you can keep a track of it and check which subjects and which chapters are useful to you. So you can attend that lecture. Okay. तो ऐसा कोई स्पेसिफिकली तो मैं आपको नहीं बता सकता, बट यस, a lot of live streamings are going on our Ekeeda channel. So whichever is useful to you, you can attend. In fact, there are for maths also there are two different categories. We have academics as well as GATE. For GATE we do have different lectures. For academics we do have different lectures. So here there are concepts like why, inside constant, outside. These concepts we teach in GATE. Here academics, these are the tricks to get the marks. Okay, anything else, any other query that you have? So please let me know so that I can answer you, or else we'll wind up the session. Today we discussed Laurent series. Next Wednesday we'll discuss line integration. On the next Wednesday we'll discuss line integration from 8:30 to 9:30, and from 7 to 8 we'll discuss Fourier series on the next Wednesday. And this live streaming will be available on channel, so you can go back and check, and you can make a note of it, and you can try solving the different problem. You can easily manage. You will get the solution. Is this clear? Now I think you are clear with how to find it out. The Laurent says, "Wow, Deepak, thank you, thank you." At least if you watch this video, we can easily score 6 to 8 marks in the exam because this is fixed topic that always come in the exam. That's it. We are ending our live session here. Hope you understood. If you understood, please like this video, subscribe to the channel, and share with your friends. That's it. Good night for valuable time. Hope I justice with your time. Okay. Thank you. See you. Take care. Bye bye.